Okay. Okay, sounds good. So yeah, again, welcome to this webinar. So today will be myself, Sami Fodil. I'm the founder and CEO of Topbyte, and with me, Mark Daly, founder and CEO of Edgevana. Mark has a very nice section where he introduces edge computing and a great overview of the actual edge infrastructure as well. So with that, I'll let you, Mark, share your slides and take it from here.
Sounds good. Thank you very much, Sami.
Sure.
And thanks everybody for joining. I'm just the opening act here for Sami, but I hope to give you a little bit of information that helps you see from a larger perspective how edge is impacting almost everything that we're doing, and how it's likely to grow considerably over the course of the next 10 years. Can everybody see my my first slide?
You're good.
Okay. Great. So, as Sami said, I'm founder and CEO for Edgevana. Edgevana is in the edge space as well, although we're not necessarily directly trying to build anyone's edge, as we're trying to make it easier for folks to consume resources that would enable them to buy from somebody like Sami or from someone else who is delivering edge infrastructure or edge platform services to the world. But part of what made us start Edgevana is tied up in this first slide, right? The edge market is expected to be worth over 1 trillion by 2030. And what's interesting about this particular number is that 2 years ago, the number was closer to 300 billion, and everybody thought that was too much. And as we continue to deploy and continue to find new opportunities, the number keeps accelerating forward. And Michael Dell is famously known for quoting that the edge will be 100 times bigger than the internet. I did some math on that and did a blog associated with that. If you care to see my math, you can look that up. It's like 2 or 3 blogs back on my LinkedIn page. And when you consider how much we have deployed now around the world, even if you only think about what's in public cloud, something around 70 or 80 million servers now in public cloud, imagine the edge being 100 times that. Imagine it being just 5 times that. The numbers are staggering, the amount of infrastructure and the demand at all levels of delivery, from the simplest of deployment tools to small to large data centers to networking, 5G, server design. Everything will be required and more. And I'll talk a little bit more about what I see as some of the important focus areas for enabling this growth and making it successful. And one side note, I always want to touch on data centers as they are kind of a foundational infrastructure item. And I found a note, I think it was, oh crap, I apologize. I can't remember the source now, but I was doing some research on edge growth in general and data center growth. And I found a couple of researchers that are estimating that data centers just for edge, which are roughly $6 billion in 2021, are expected to grow at 26% compound annual growth rate through 2030. So that's just a massive number. That means that just edge data centers will be bigger than the current commercial data center market that's been around for 25 years, just in the next 8 or 9 years. So keys, right? These are extremely high level, but provide a focal point for consideration in how you approach the edge when you're thinking about partnering or when you're thinking about doing it on your own or some combination of the above. But horizontal scale needs to be simplified. What can't be expected to work, what shouldn't be assumed to work, is taking something that you're comfortable with and have been using and trying to stretch that out over a distributed edge. You have to break all of your assumptions first. Breaking your assumptions means reducing operational management overhead. What does that mean? Well, it could mean finding a way to get a partner with resources that's distributed all over the world already, like a DHL, to be the person that goes to your little data centers or your partner data centers, however you've arranged it, and you've made an arrangement with DHL for them to be able to swap in and out hardware in your little data centers, just as an option. Another option is to rethink what a server or a storage device or even a data center looks like. I've been building and managing data centers and cloud infrastructure for most of my career. And what I can tell you is that the data center industry as a whole is filled with assumptions about what it can and can't be done. And generally speaking, is very risk averse. Well, I'm here to tell you that we have to break those assumptions if we're going to expand at the edge and make it successful, not only environmentally and sustainably, but also just from a cost of ownership standpoint. So when you think about a server, servers have fans in them, data centers have air conditioning in them. Do they need that? Not always. You'd be surprised, but not always. So that's just one example of things that could require a second and third look before attempting a strategy on your own. Create a smarter approach to how application environments can be built and deployed, right? And this, it really aligns with what Sammy is likely to present on. Your ability to deploy applications simply and consistently across a diverse set of infrastructure is likely to be part and parcel with living at the edge, at least in a highly distributed model. So what's leading us here? These are just a few, but digital transformation, value of data, which is growing, as everybody knows. I mean, everybody hears it almost every day. Data is growing exponentially, blah, blah, blah. Yes, it is. But what I'm hearing from people that are actually deploying at the edge now is that they are creating more data than they even expected. And that in some cases, they're building edge infrastructure not because they were worried about latency, but because they can't solve for the problems in the facilities that they're building edge for if they have to ship the data somewhere else, because there's just too much of it. And many of the folks that are looking to build edge infrastructure are looking for that location to be able to run independent of a network being down, let's say to AWS or Azure or Google Cloud. So the collection of data has become integral to why edge is being deployed and how you have to think about valuing and protecting edge. And of course, COVID-19 has accelerated almost anything and everything, as we've all probably heard this 100 times now, but it goes without saying that as part of digital transformation, COVID-19 has accelerated that race, and by virtue has accelerated many of the other things that I'm referencing here relative to edge. I'm not going to read all of these. You're free. If you're interested in seeing the slides later, just let Sammy and Ash know. I'd be happy to send them to you, or you could contact me directly. But IDC says that companies that are successful at business or digital transformation are seeing faster revenue growth, stronger profits. I always focus on digital transformation from the customer perspective. And this is just a little bit of evidence from back in 2019 that for most transformation efforts, more than 50% certainly, it was about providing a better touch point for customers. So being able to connect with customers more effectively. A transforming company is a technology company. What does Mark mean by a technology company? Well, I don't have a lot of time, so just one quick sample. In 1985, Sergey Brin and Larry Page decided to found Google. They had an empty warehouse and they decided to buy some books and turn it into a library. There you go, 1985, that's Google. If you had sat down with the two of them and said, oh, by the way, you're going to need 300 data centers with 100,000 servers in each, and be spending somewhere between 10 and $20 billion a year in infrastructure because you'll be a $100 trillion company in 30 years, what do you think would have happened? They would have been laughed out of the room. And yet that's what a digital transformation can have, a true digital company, because Google is in fact a giant library. Obviously, they've added other services to that platform, but that is their foundation. They are a library. So it is very difficult for me to accept the notion that almost any company going through digital transformation won't find reason to provide more of their business via digital means. And what that means is that more and more people will be deploying more and more technology. And that's likely to be seen in at least 15 to 20% of enterprises increasing their technology spend by anywhere from 100% to 400% over the course of the next 10 years. As an example, PayPal is a bank, but they are digital, and they spend roughly 40% of their revenue on IT. Yes, they call 35% of that 40% engineering, but the fact is that it's IT. So with the right culture, the appropriate organization, a vision for what company you are and how DX supports that as a platform, your enterprise's ability to respond effectively and quickly to employee, customer, partner, or supplier requirements will be what differentiates you and your business, helps it survive. I'm not going to read through all of these. Again, you're welcome to take a look at the slides if you'd like to see them. But it's clear that they're calling out digital transformation as a fundamental area of opportunity directly associated or being accelerated by COVID-19. And what I'm saying is that Edge is a natural opportunity associated with digital transformation. Digital transformation, if you follow along with what Mark says, if you believe what Mark says relative to the power of digital transformation in helping to reach customers more effectively, and in fact being mostly about the customer, then you have to make the assumption that a significant portion of these companies doing digital transformation will be finding new, interesting ways to connect with and get value from the relationship they have with their customers. And that means tearing down the assumption that your customer contacts are email, phone trees, and a flat web page. What's the great way to help solve for that? Edge computing, right? So edge computing is a natural connector to digital transformation, as if adding arms and hands to the body of corporate America, corporate world, allowing the corporation to reach out and touch and convey trust, convey warmth, convey connectivity, et cetera, et cetera. So again, it's about the customer. Differentiating Edge provides you opportunity in all of these areas. Differentiating on performance. Does your web page load faster? Can you guarantee potentially a higher level of sales? Does your game perform better? Is the website more engaging? Can you as a company turn on data that you're collecting at the edge more quickly, which is directly associated with digital transformation? Can you generate more loyalty? Any one or two of those items could be the difference between success and failure against your competition. Certainly all five of them would make you a monster in a good way. Like it or not, limiting human involvement, right? So whether we like it or not is immaterial. I also wrote at the beginning of the pandemic that the pandemic was likely, in the very beginning, I mean like March, I think, last year, that the pandemic was likely to increase the goal of automation and the reduction of hand touches on process, putting it bluntly. And I think we can all agree that that has been a major side effect of the last 12 months. So really quickly, just breeze through these before I turn it back over to Sammy. But this is what I see as kind of the first, second, and third order of development at the edge. Basic IoT, factory floor, smart buildings, certainly gaming, et cetera. Access and deployment improvement, infrastructure marketplace, simplified deployment options for devs and end users, AI for real-time data husbandry. Husbandry is actually a term from Rich Miller. I like it because it seems very inclusive as to all of the different aspects of taking care of your data, from sovereignty to compliance to quality to retention. And biz models on top of early deployments. As more and more gets deployed at the edge, additional service and business models will be developed on top of that data or on top of that infrastructure or both. So information technology isn't an immovable fixed answer. Easy for me to say. Challenge your assumptions. Consider the value of being front and center with customers. and don't think you should go it alone, right? Don't think that you have to solve this on your own. There are great people out there. Taubyte is a perfect example, working on solutions that can dramatically simplify your approach to edge computing. Thank you very much. And with that, I'd like to turn it back over to Sammy. Let me stop sharing here.
Cool. Thank you, Mark. And while I'm sharing my slide here, I would like to add that historically speaking, the edge preceded the cloud, right? So companies like Akamai existed way before the cloud was a thing, or companies like AWS existed. And that's just a little fact here. All right, sounds good. Let me start here. So I'll start with going through what software is and how complex it is to build software today and how to solve that. So software mainly can be resumed to two units: function and data. Now let me put this together, because everything that's going to go around that is kind of like pretty much the same. So function and data is really what you want to deliver. That's what's impactful about software. But to get to that, you need to do other steps. So you need to build service around that. So either code you write or a software you're using, and that's a resource behind that or more. And then you need to build a container or something where you ship your code into, and that's images to maintain and more people behind that. And then, well, now you need to build that code and then push it. So you need to write and maintain pipelines or CI/CD pipelines. So you need more people, and now you need tools. Not to say, I think the DevOps market is a few billions, and that's like last year's estimation. And then now you need a load balancer, so you can balance the request over multiple instances in the same data center, and that adds cost and more resources managing that. And then now you need to orchestrate all of that, so you deploy it to the right instances in the right places. Then you need to monitor that and maintain that. And again, you're adding resources, then you're using more tools. And then now you need to do networking, so static assets, and then cost comes with that, and then more resources managing that. And then you need to configure all of that. Push config, write that config, maintain it. And then again, more resources, more tools. And then now that you have all those resources and all those tools and all the usage you're doing in the cloud, in this case, you need to optimize costs. So those are other tools with other expenses that comes with that. So that's how complex software is today. And this is just for one service and one data center, one region in the cloud. So, and it is backed by data, right? So studies show that 47% of enterprises consider cloud complexity a primary risk for their investment in the cloud originally. So what's happening? Why do we have that complexity? I like to present it in those 3 points: centralization, fallacies, and hype. Now let me start with centralization. So how do you get data today? It is like an example here from HTTP. How do you get a service like a REST, a service to kind of process your data or get an image or a website and so on? So the first thing you do is you need to know the resource you need to get. And then you need to know in advance what is the path and who is providing that. And that's very dangerous, because you need to know that in advance. So it needs to be in config or it needs to be in code. And then the other thing is, if that changes, you don't have access to that anymore. And then the last thing is communication is through a protocol. Here it's HTTPS. The communication is secure, but how can you guarantee that the other side is really who it is it pretends to be? Like we've seen recently in the news companies that got got attacked and hackers get into, and then they were able to access cameras in Tesla's factories and other places. That's the benefits of centralization. So one point, if you hack that point, you hack the whole network. So, and this is kind of like resumes what I have here. So it's true that it's simple, but it's very hard to scale. You have this static and immutability that you need to have like all those values around. And if something changes, it breaks everything. And then you have a large attack surface, so it can be compromised easily, and people can steal data easily because it's one central point where you get the data. So for one of the points I mentioned, which is like those values that we maintain, there are means to solve that, right? But the means out there, like Istio or Kubernetes, they're also centralized services. So they kind of have the same problems. Kubernetes is very known for its complexity and its security issues. ICO is very complex product as well. And then now let's go to the fallacies. So because of all that complexity when developers write code, they'd like to think like the world is better than it is really. So they like to think that the network is reliable, homogeneous, and secure. There is zero latency. Bandwidth is infinite and transport is cheap. There is only one administrator that can change things, and topology doesn't change. So it's static, it's immutable. They like that, it's simple. But what happens is errors and bugs and stuff's not working, right? This is what happens when there is a little code change, when a DevOps or an administrator changes an IP address, and so on and so forth, because all those static links between stuffs. All of this is managed through humans that Mark said they're not very scalable as we move to the edge too. And then what ends up what developer ends up doing is writing a lot of what ifs. What if this goes down? Oh, let me wait for this service for 100 milliseconds, and then this other for 200 milliseconds, and all of that goes into code, and all of that goes into ops code too, and it doesn't end, and you can never predict everything. As a matter of fact, even the best out there with the rockstar teams out there do go offline and do not work when something unexpected happened, like what happened last November when AWS went down, and Ring, iRobot, and other product didn't work anymore for hours. So that's for the fallacies. On the hype side, there is in technology, people like to adopt stuffs that are cool or hypey. That happens a lot in web framework, but it also happens in infrastructure. A good example is Kubernetes. So Jason Bloomberg back in 2018 said that. So today there's no question that Kubernetes is so shiny, you need to wear shades just to talk about it. The question we must answer, therefore, is whether the excitement around the still new Kubernetes has gone overboard, leading to counterproductive shiny things scenario. And what happened since, so there are studies, recent reports, that shows that 38% of developers and architects feel extremely burnt out working with Kubernetes. 78% of developers and architects claim that Kubernetes adds-on cause a great deal of pain and introduce complexity, along other concern about Kubernetes security. Like I said, Kubernetes is very known for its flaws in security as well. So now, like, I just wanted to kind of like paint a nice picture of what software is. So when I talk about the other points I'm going to talk about, it makes sense, because now we want to take this model and try to scale it to the edge. But before we do that, let's take a look at what the edge is, right? So when we look at the edge, it is a spectrum. So it's not one place or two places, it's a spectrum. So it goes from device edge, which are the IoT device, for example, or a VR set or a smart car, and so on and so forth. And there are services and there are servers and devices between that and what people refer to the cloud, though the cloud doesn't have to be the end result or where the data should end. Like the cloud is more like long storage maybe, or a warehouse for data to be processed for business intelligence and so on and so forth. So going from the device edge, we have trillions of devices, and then smart device edge, we have billions, and then on-prem millions, and then access edge, we have over 100,000 of them. Regional edge, here it's 10,000. This is an LF edge prediction or estimation, but I believe, and Mark would correct me on that, but I think it's way more than that. And centralized data centers is also way more than 100. I think like AWS is around like 24 data centers so far. But what is the objective of the edge? And Mark talked about that, but mainly it's to guarantee response time, ensure continuation of service, reduce costs because it's very expensive to send data to the cloud, protect privacy because the moment you send your data to the cloud, they're not private anymore, right? Even if your communication is secure, once they land in the cloud, they're not private. And this is what Mark awesomely referred to husbandry, right? A new word for me. And the last one is reduce attack surface. So let's say you attack an on-prem data center, you're going to affect only a subset of the network. But if you attack the central point, which is the cloud, you're affecting the whole network. And then let's not forget the space. So we're launching edge compute into space. How awesome is that? So HP, Microsoft, and NASA are launching computing in space, and I'm pretty sure that this is going to grow more and more with like a swarm satellite being launched into space and so on and so forth. And that's very, very exciting. So obviously, at this point, you might think, okay, so we have this very complex or these very complex tools and this very complex approach from the cloud. Can we really apply it to something as big as the edge? And the answer is not really. It's pretty problematic, and there is good reason for why. So the edge is distributed. It has intermittent connectivity. So I'm talking about all those fallacies that developers think that like they exist. Like they think that connectivity is always there, while at the edge is intermittent. So we have hardware diversity, and not just Intel. We have Intel, we have ARM, different versions of ARM, and more hardware is coming up, Sci5 and other CPU architectures. We have physical and security. So let's say you deploy a camera out there, and that camera is running software, and it's connected through VPN to your cloud. How about someone getting into the camera because they have physical access, and through that VPN getting into your cloud? Right, so that's quite dangerous, right? And then it's dynamic; it's always changing. IP addresses are changing, topologies are changing. It's changing all the time. So, what is the solution? You might think. Well, we think that the solution is a smart platform that can intelligently and dynamically handle software and ops complexity at scale. And we have a name for that. We call it smart computing. And I quoted that last year in a blog post that you can find on our website or on our blog. And after all, right? So we've done that before for a lot of things. We automated banking, customer service, factories. We're automating cars. We're using automation and AI to, like Mark quoted, reduce the human touch, because at the scale of the edge, you cannot afford that. That's a reality. So the question that you might have now is, okay, so we know that that's a problem. We know that we cannot use edge native tools and centralized approaches and architectures. Now, how do we solve that? How do we approach that? So I think that those four pillars are the basis of solving the problem: node intelligence, self-healing, portability and interoperability, and smart routing. Let's start with node intelligence. And if you look at the architectures today, and even if you look at what LF Edge is doing, for example, they have a separate product a separate set of config and so on and so forth for each use case and for each layer of the edge. But if you look closely to the most amazing computing thing we know of, which is the brain, all neurons are the same, except maybe a little bit of like difference, but they're all the same. And there is no client neuron and server neuron. So we believe that node intelligence means that it's a true distributed system, like the brain is. It should also have the ability to automatically discover peers, services, and data, so we don't have to rely on static configs and immutable configs. And then the last thing is smart ops. And smart ops means that each node, before providing a service or forwarding the request to another node, can determine if that service could run locally or should run in a neighboring node. And that's kind of like permits to implement complex requirements for private 5G networks, for telcos, and so on and so forth. So it's not just like, oh, you're going to be routed to the nearby node. It's more complex than that. Now we call them smart ops for a good reason. So they're very similar to smart contracts in blockchain, except that instead of applying to transaction, they apply to operations. And then the second point here is self-healing. So because of that intermittent connectivity, we need to have systems that can work offline and that can be resilient to partitioning. So if a group of a subset of the network goes offline, should be able to come back online and merge back with the rest of the network. And this is and to accomplish that, we need to use conflict-free data replication technologies, or CRDTs. So we don't rely on a centralized node. Oh, tell me, or rely on a master node, elected or not, like Kubernetes elected a master node through Raft. But if that master node goes offline, they'll need to wait until they elect another node. And meanwhile, nothing can happen. What we need, because of the dynamic nature of the edge, is something that can merge back together with no conflict. And this is why we need CRDTs. And then the next one is portability and interoperability. So at the edge, like I said, like you cannot really rely on IP addresses. I mean, if you look out there, you'll see a lot of IP addresses in Kubernetes config or IOFog, for example, which is an LF Edge product. You see IP addresses there. You see usernames. You see SSH keys and big configs. You cannot do that. This is very specific to network. This is very specific to that use case. And if you change the node, if the node moves, you're breaking everything. And we need to be agnostic of that. And we need to be hardware agnostic too. Leveraging technologies like containers. Yeah, I know containers are cool, but containers are portable, but they are not hardware agnostic. So if you look into technologies that are using containers for IoT, you will have to maintain different container version for each CPU. So you'll have, like, for example, an Intel container and an ARM container. And then for ARMs, well, I mean, you'll have to figure out which version. So V7 specific container, V10 specific container, so on and so forth. And the next thing is programming language interoperability. So really, like right now, when you build something, it's pretty hard to make interconnection between different languages unless you use like some higher level protocols, right? So you use REST or you use MQTT or like any messaging protocol. Now, what if I write my code in C, for example, but there is this cool library that can do facial expression that's being written in Go. How do I do it? Do I create a client-server topology on an IoT device? That's kind of like very, very complex, right? So we need to have a way to link together software that has been built from different languages. And then the last thing is universal data addressing. So different systems create different type of data. How do we link that data together? We need to have a universal way of doing so. And then the last thing is smart routing. So remember when I presented the centralized example of getting an HTTP resource? It was HTTP, address, port, path, and resource. That's centralized. You need to know a lot of things ahead of time. Well, the way around that is to address nodes, address content, address services or functions using their hashes. And then we can, at that point, we can rely on a DHT, distributed hash table, that is used by peer-to-peer systems for a long time, a very resilient technology to find what we're looking for. So we can ask our peers, say, oh, where is this file? Where is this function? And because peers can provide that near us, it's a native CDN. So we don't have to deal with, oh, I've built all my stuffs in the cloud, now I have to use a CDN service. You don't need to do that. And then what we add to that approach, we add that smart ops that I mentioned before, so we can do an intelligent routing as well, depending on the requirement of the network. So great, right? Like all of that sounds great, and the only thing we need to do is to build it. Well, you're lucky because we already did at Talbyte. And we've built the first smart computing platform. So it's a platform that provides developers with the simplest path to build, run, and scale edge native applications. So resume to two things, and I'll show that later on. Write function code or write your code, push to Git, and that's it. There is no DevOps, there is no setting up a service, there is no IP addresses, there is nothing like that. And a high-level overview is this. So basically, you can see the edge infrastructure in the bottom. It's very changing, it's very dynamic, and we build on top of it. So we build a resilient overlay peer-to-peer network, and it's infrastructure agnostic, and then we bridge to IoT protocols. And then we have a blockchain layer on top of that. And by blockchain, I mean ledger, right, or a distributed ledger. I don't mean like a coin or a token. And that permits us to secure data and software. So if a node gets data from another node, which is a very huge use case at the edge, like machine-to-machine communication, it can verify, hey, is this coming really from that other node? Or is this function you're giving me has been played with or not? Like, we need to verify that. And this is what that layer does. And ensure also consensus through CRDTs as well. And it does also other steps, like the blockchain layer is blockchain is a very important topic at the edge, and it will take more time to discuss it, but at Talbyte we ensure that we provide that out of the box. And then the last layer is the orchestration. So we run the smart contracts, and we deploy code where it's needed, when it's needed, and then we execute them into WebAssembly virtual machines. So they're secure, they're fast to spin up, and they're hardware agnostic. And then if you see it on a higher, like kind of like 1,000 feet view or something like that, you can see that it's a peer-to-peer network. And then we'll have like the Talbyte main network of nodes. Each node is almost similar to every other node. So they have ledger, storage, database, message broker, and function execution services. And they can provide any of those as long as the smart ops validates that. Smart ops contracts are also written in your favorite language and compiled to WebAssembly, by the way. And then Talbyte can go very small. So can be deployed in very small devices, can be deployed on a server, can be deployed in the cloud. Then it forms this peer-to-peer network that enables all that intelligence. So as always, like if DHL, I mean, Mark mentioned that, and the postal service and all of that, and internet didn't exist, Amazon wouldn't exist, right? And it's not me saying that, it's Jeff Bezos, right, in one of his presentations. So again, like without these awesome technologies, breakthroughs in distributed systems, CRDTs, and portable computing, libp2p, IPLD, WebAssembly, here as an example, Talbyte wouldn't exist, and we wouldn't be able to build this amazing system. So let's see how powerful is the Tau. So this is an example of a workflow. So doing this on Amazon or any other service will be crazy, and you will have to spin up multiple servers and do a lot of config, and it would be crazy. So it starts with exporting your token or Git token. You can do it in a file or just export it here like I did for the example on the terminal. And then you create a project. So the project will create 2 repos, one for config and one for inline code repository or inline code. And everything is around that repo. So if you change config, it is going to be auditable, right? We know who changed the config and why did they change the config. Then as soon as you change config, one of the hookers, it is also a node in the network, will pick up a job and then compile your config, push it to the network, or compile your code and push it to the network as well. So you can see here that I'm going to the project. So I'm just doing a CD, and then I'm doing Tau application new, my app switch. So it's going to use that app, so I don't have to specify it in the next command. And then I create a domain. This will give me a token that I'll need to add to my DNS, so Taubite can know that I own that domain, and then we'll be able to reply to request, and then we'll be able also to ask for a certificate from like a dynamic certificate or an Acme certificate for HTTP, for example, from Let's Encrypt. And then the last thing, I'm creating a function. I'm writing some code there. I'll show you the code in the next slide or upcoming slide. And then I just push my code, push my config. And again, you can push the config before the code or the code before the config because of the CRDTs, right? And then finally, I curl, and then I have response. So a node that's nearby responded to my request. And that's it. It's as easy as that. And then we can provision more than just functions. We can provision whole single application websites. We can provision config and so on and so forth. And that's it, magic. And then let me also, we have a web UI if the command line is too scary. So it's login, and then you create your project, same thing, exactly the same thing. And then you can register your devices. It will give you, if you have devices that we want to add to the network into more like your private network. So we'll give them an identity so we can verify that it's the right device. We can verify their data and so on and so forth. And then you can create a function. Here I created a C function that just reply with Pong, and that's it. And then you push your changes. There is a little button to push that to Git, and then you can ping that IP that URL, and then you get the response, and that's it. So that's Taubite, and that's how we approach edge computing. And our goal is to build interplanetary scale intelligence and give the tools to developers to do it. And that's it. So I think we're open to Q&A here. So if you can either post in the chat or raise your hand, and then we'll unmute you. Right, Ash?
Yeah. Currently, I'm not seeing any questions in the Q&A, so, but feel free to address your questions through the chat or the Q&A.
We got a hand up from Doug.
There we go.
Yeah, hey guys, can you hear me okay?
Yep.
Awesome. Yeah, so something to kind of open for discussion, and a lot of great points that you and Mark and Ash have brought up during the session, where it's going to take several people to be involved and not really be intimidated where you've got like a real secret innovative that you don't want anybody to steal, because as you guys have found out as edge solution providers and Edgevana and ourselves, is that there's so much work to do. It's going to take collaboration from a bunch of different companies. And some of the points you touched on, and coming from an enterprise world, is getting the acceptance into enterprise at that large of a scale, because they're so entrenched in the cloud. A lot of it is heavy Java development. And a lot of the Java developers, they lack some of the skills that you may have mentioned about multiple different languages and having the language bindings to be able to live within the Taubite cloud environment and infrastructure. And even when I was in that environment trying to propose like C++, there was a lot of C++ experienced developers there, but we were writing in Java, but still management wouldn't sign off on moving to some CS++ development. So I guess my point of this discussion is working together. How can we send the message and kind of get the enterprise to be receptive to our edge offerings? That's kind of a challenge that I'm facing, and I'm sure others are facing as well.
Yeah, I mean, I think I'll give you my answer, which might be like your question level technical, and then Mark can probably add on that. So I think so what we're seeing are like, the edge or IoTs in general. Like right now, it's the biggest or the most mature edge use case or edge computing use case. Most companies want bundles or turnkey solutions, right? Those are still complex solutions, and that's our goal. Our goal is to kind of like tell them like, hey, instead of using 3 or 4 or maybe more components that are very complex and very hard to scale, like you can just use your existing workflow, like of writing in any language you like. A lot of languages compile to WebAssembly, and then using your workflow, like pushing to Git, right? And then everything actually goes around that. So for example, let's say for example you're pushing some secrets into your Git repo, and you don't want another team to have access to that, but you want them to build a specific libraries with specific functions, right? We allow that, right? So you can create another repo that's only for that library and manage that access from Git, right? Where it doesn't change your workflow. So I think like, and that's what we're trying to do, not change developers' workflow. They like the language they like their Git workflow. Let's not change that, right? Now I agree that when you go to some places, they don't know Git, and they work with other tools, right? So they might use like tools that are more like maybe go back like 5-10 years ago, right? Where they're not like like I said, they're not hype, right? Going back to that term, right? So they will build monolithic applications with maybe like a Windows monolithic application and stuff like that. And we've seen that. Like, why would anybody use Windows to build IoT solutions? But we've seen that, right? That's kind of my technical answer, and Mark probably can add to that.
Yeah, I mean, Doug, first, I think you had a great answer. And you're right, mine is likely to be considerably less technical, Doug. But as someone who has been in a position to try to get projects approved numerous times and tried to move organizations towards some level of modernization or adaptability, I can tell you up front that there is no single way to make that work, right? There is no one. It's like going to an investor or going out on a date. There's no one way to always get the right answer that you're looking for, right?
Right.
But what I would say is that the more you can help the business understand that what you've considered about how the company does what it does today versus what the opportunity of where you're going might create, then the easier for them to realize, look, this guy has made an investment. He's looked at, and I'll give you some examples of what I mean, what's buried in my comment. If this were me, I would say, okay, we have 20 coding staff, and we have 15 operations staff. And the coding staff is, the vast majority of their skill sets are in C++, and a few maybe have older languages that they're using for the mainframe we still have, or something like that. Or pick your combination. What the business has to accept or decide on is what amount of change is justified for the solution being requested. And they have to put that up against not just the opportunity of that change, but they have to put that up against the impact to the existing team. And the impact isn't just, oh, we need to get them training. or we need to hire some consultants. The impact is residual complexity, residual change to the status quo, right? And this is where some of the other complexity comes in. If you're talking to your head of infrastructure or head of applications, and their focus is just on not letting things break, as opposed to actually trying to make forward progress with new technologies, then you have to cater to that in some level. And you have to say, look, this is where technology is going. What I recommend is we do some recruiting within the staff. We identify a few people to take some courses. Maybe we pick up a part-time external coder who has deeper experience, who can help us along. And we work with an architect to make sure that what we're building can be incorporated, that we can use APIs if we need to, we can exchange data if we need to. But there is no simple answer, because it will be dependent on your organization. And that's why I said what I said in my presentation, where, don't be afraid to approach partners, because what I'm finding, in fact, I'm thinking about writing a blog about it. What I'm finding is that an enormous number of people in this space don't believe that there are good answers available for them, either because of what their management has told them, or because of the noise in the edge community, whatever it is. And that has caused them to do one of two things: either to hesitate and not do anything, or two, to believe that they have to create their own bespoke solution. And I can tell you, I've looked at some of the bespoke solutions and they work, but there's that's like saying there's you and your kid driving to school every day, and you buy yourself a giant bus to take the kid to school. Yes, it works, but is it the right thing? Not necessarily, right? Yeah. And so anyway, I could go on and on about this, Doug. And Doug, you've already reached out. You want to talk. If you want to talk about this more when we connect, happy to talk about it more then too.
Cool.
Sure.
Yeah, thank you, Doug. Yeah, we have a question, by the way, from Mayank, and the answer will be pretty quick here. So yes, Mayank, we're going to release access to our platform in the upcoming weeks. If you go to the website, there is a sign up link for beta access. You can sign up there, and then we'll ping you when it's available.
Well, we have another question, Sammy, from Greg. So where are you on your commercialization journey, Sammy?
So to answer this question, so basically, we do have clients that we're working closely with. We've been working closely with for some time now, and there is a reason for that. I mean, since the beginning, we believed in the lean startup methodology, so we wanted to build what the market needs and not build an awesome product that the market doesn't need. We have a lot of beta sign up for a number of enterprise accounts, and as I said, like, we're going to release that in the upcoming weeks. And I invite you to sign up as well. You might very well enjoy it. And so right now, if the question is more like go to market, so we have also built partnerships with OEMs. You know that a lot of IoT products out there is just bare hardware, and it's pretty hard to take advantage of it. This is where we go to that most people need kind of like integrators that take that hardware and put some software and kind of build that bespoke solution that Mark was referring to. Build that big bus that might not scale to drive through the school, right? And then we do direct sales, and with the launch, we're going to focus on also building a developer community. And then
there's one more.
There is another question from Merwan, and
can you repeat or paraphrase?
Yeah, so the question is basically if you're building a web app which has like a front end and a back end, how would that work with Talbot? Yeah, so I just did an example for a simple call, but you can also create a website on the platform, and then it will create a repo for you when you can drop your website. And the idea is like that your website would have calls, right? So you're kind of like building a D app or a D web app, if you wish, right? So you can, let's say you build a Vue.js app, you have that in the repo. Once you push your code, we're going to build it. It will generate the app. We're going to push that to the network, right? And then any node that has a request for that and determines that it can serve that, it will serve your index file. And then the index file will spin up the single page application. And then you can have calls there. Now, instead of worrying about which service to connect to or whatnot, you can just use your domain that you have functions connected to. Then it will connect to the nearby node, have your data processed or have your data stored, or create, you can create like a pub sub and communicate between two apps, like create a chat app if you wish, or like even like a Google Meet clone and stuff like that. So yeah, and like, yeah, basically it will be a D app. And by D, I mean distributed, not decentralized. Yeah.
Cool.
I think we're about time here. So I think we should maybe if there is one more question, we can do that. But otherwise, I would say thank you all for attending. Thank you, Mark, for your great insight as always, and Ash for taking care of organizing this webinar.
Sounds good. But before we wrap up, and Sammy, thanks for inviting me. It was my pleasure. Doug, did you just raise your hand again? No. Okay. All right.
Cool.
Thanks, everybody. Appreciate it.
Yep.
Thank you, guys.
Have a good night.
Weekend. Bye.
Bye.